time is it anyway?
Okay, I wanted to get a video out about this one. This one question from the test that was kind of clever and unique, and nobody really got the idea what was going on here, although some people had different ways to start off on it, but it's actually much easier once you realize there's kind of a trick to this one, so I thought it was an interesting one to include to see if anybody made good use of these transformations. I did put a hint with the problem that said use transformations on it, and you got a couple of points if you tried some stuff out with this thing, but it's you got to catch on to the idea of it before really going to have much luck. So test went overall pretty well. We had like a 73.7 average on it, so pretty good results on the test overall. Different mistakes here and there, pieces that were missing, but good work on that overall. This one, a lot of people lost some points on this, but I said to find the equation of a cubic function that goes through these 3 points right there, and the hint was to use transformations on it. The concept being, since these 3 points are all at the same y value, and a few people actually drew this out and marked the points on it, which is a good start on this thing to know what's going on with that. You could have a cubic function that fits that. Those are that seems doable, the shape of the thing. But the idea is they're all shifted up a little bit, so the concept of it is if I've got a function that's here, here, and here, then I can just shift it up +3 and hit those 3 points. So all I need is the cubic function that has zeros at these 3 points. And that's the cubic function that would go through -2, 0, 3, 0, and 5, 0. And if you take that cubic function and shift it up 3, then you've got the cubic function that does that. That's going to go exactly through those 3 points. Any one of those numbers that you plug in here, you'll get 0 for this part +3. So f of each of those things is going to be 3. It's going to work out great. So you may not have realized how powerful you are with these transformations and this idea about knowing where the zeros are. But basically any number of points, if they're along a horizontal line, you can come up with a polynomial that hits all of those points by writing down, more or less just writing down the polynomial that has these zeros, and then shifting it up a certain amount, you can hit all of those points. So any number of them, you could find one of the appropriate degree that goes through all of those points easily by that technique. So that's maybe it's a useful thing. It's kind of an interesting use of what we were learning about. That's why I included one like that, but I wanted to get a video out on it so that I can unveil the mystery behind that one. Other problems on the test were pretty conventional, but this one was a little of a combination there. So I have something out about that, and I'll have a video out soon about the exponential and logarithmic functions that we're heading into next.